Hello everyone, myself Mr. Manik Rajangale from Department of Mechanical Engineering, Maratha Engineering College, Belagavi, Karnataka. So we have a discussion today on the topic called the basics of engineering thermodynamics. Okay, what are the few basic things of engineering thermodynamics? In that we are going to have discussion on this introduction about this thermodynamics, then the course of the thermodynamic, then the system and the types of this systems, types of thermodynamics, and also the properties of thermodynamics. Okay, so let's see, starts with the introduction of the thermodynamics, and under the introduction first we'll start the term thermodynamics is derived from the Greek words, the two Greek words, and they are therm means heat and the dynamic means the flow or motion. Ultimately a thermodynamic means it is the heat is under motion or the heat is under flow. Heat is also a kind of energy. Okay, so fine, let's see exact the definition of a thermodynamics, what it says. So definition of thermodynamics says the thermodynamic is the science of energy transfer and its effect on the physical properties of a system. What says? It is a branch of energy transfer and its effect on a physical property of the system. Let's see this, the definition I will explain, describe with the help of day-to-day life, the example. Let's see here, what we can see here in this image, you can see the water is boiling on a stove. In our kitchen everyone sees this, the phenomena water is boiling on the stove. See here, this is what the stove which is provides the energy. What here the gas, after burning the gas, heat is get liberated, that heat we are transferring to water. Okay, see here I will show this. What the definition says is, this is the branch of the energy transfer. Okay, so here what is this? This is the energy which is going to transfer, that is what the heat energy. This is a heat energy which is going to transfer to the fluid or the water which is stored in a container. Okay, so this now first part is what? It is a branch of energy transfer. So we can see here, this is a heat energy, how it is get transferring from the source to that system, which is what? The water which is present in the container is our system. Okay, so then the second part says that it shows the effect in physical properties of the system. So then what is the physical properties here? The properties means that any measurable characteristic of the system is called as a property. Let's see then what are the properties of this water here. If you look into the water, obviously we know that when you start sitting, what is the first thing you observe? The rise in the temperature, is it? So temperature will going to be rise. So as the water gets stored in the container, it has certain mass. Yes, it has the mass also. Okay, so it has certain volume, isn't it? Has certain energy. It has certain energy, means all these. Okay, it has the mass, it has temperature, it has volume, it has certain pressure, it has the energy. See, these are all what? The measurable properties of this water. So water which is present in this container we are considering as our system. Okay, so these are all the properties. What says? As you go on transferring the heat energy, so what? The initial, if the temperature is a room temperature 25, now after the 5 minutes of the continuation of the heating process, temperature may rise to 35 degrees Celsius. Here what? Any one of the properties of the system now starts changing. Similarly, it is a liquid state. When you go on adding the heat, its phase is get converted into the vapor. It starts evaporating, converting to liquid to vapor. So there the volume get changes. Okay, so mass will be energy get changes. So these are what? Is all the changes of the properties happen only because of this transfer of the energy. Once the energy get transferred, then that shows the change in physical properties of the system. You can see here in the previous slide we have discussed that the thermodynamic is the branch of energy science. There we have discussed how the heat energy transferred to the fluid. Then how after transferring that energy, its effect on the properties of the system, physical properties. There we have learned that how the mass is going to be changed, mass and the temperature changes, the pressure as you go on heating, so energy got changes, the volume got changes. These are all what the properties of the system. Okay, so these all changes happens only because of the transfer of heat energy. This is what says the thermodynamics, the definition. Let's see that. Next we see the scope of this thermodynamics. What are the scope of this thermodynamics? We cannot imagine the life without the thermodynamics. In day-to-day life, the energy is required. We cannot imagine the life without the energy. Okay, see this, the scope of thermodynamics, under the scope of thermodynamics, experimental observation is the basis for the thermodynamics. Just I have explained this, the definition with the help of this experimental only, that how we are boiling the water with the help of that heat energy in the gas tube. Similarly, that is why the experimental observation is the basis for the thermodynamics. Based on the observation and the experimental result, certain laws were developed, and they are the zeroth law, the first law, second law, and third law of thermodynamics. Okay, so these are what the laws derived after the experimental result. Okay, then these later on we see that in details what are these laws, zeroth, first, second, third law, we'll discuss later on in details. Okay, so what are the applications of this thermodynamics? Okay, so these applications of the thermodynamics found in most of the energy technologies. Okay, few examples are there, the steam and the nuclear power plant, and the IC engine is there, the gas turbines is there, air conditioning is there, refrigeration, jet propulsion. If you see that the steam and the nuclear power plant, where the power is going to be get generated. Okay, how the electricity gets generated? By the water is converted into steam. Here, to convert the water into steam, there also heat has to be get supplied. So this is when the heat is get supplied, that liquid is converted to steam. This is how, again, what says, this is a branch of energy transfer and its effect on the physical properties, means that liquid is converted to steam. Steam has a high energy content, so that is expanded in the turbine and produces the electricity. Same thing, by burning the nuclear fuel also will generate the heat energy, and through that heat energy will generate the steam, and expanding in the turbine, that gives us the electricity, a power generation. Similarly, in the IC engine can be used for the automobile system and also for the power generation. Similarly, the gas turbines for the power generations we are using. The air conditioning systems we are using in household. The air conditioning means the conditioning air as per our comfort, as per our requirement. Okay, so that is the air conditioning. There also these terms are required here. The refrigeration, if we are familiar with this term refrigeration, now in the summer season everyone knows that without the refrigeration we can't imagine the home, isn't it? So in the refrigeration also, that the part is what, the thermodynamics only. It is the application of thermodynamics. And similarly, the jet propulsion is also the part of thermodynamics. These are the few examples I have discussed here. So based on this, the thermodynamics. Okay, so let's see the next here, the system. Now up to this we have discussed that what is the thermodynamics, what is its definitions. Okay, so then what are the scopes where we are going to use this, the thermodynamics, the applications. Let's see what exactly the thermodynamic system and the types of system. Okay, so what is the system right now? See in this here, this region, what is a system means here? System is certain region or the matter in a space upon which our attention is focused for the study. What? This is the certain region in a space upon which our attention is focused for the analysis. Okay, so always the system has its own boundary. You can see here it has its own boundary. Because of its boundary, it gets separated from the surrounding. Everything external to the system is called as surrounding. Everything external to the system is called as surrounding. Okay, you can see here this is a system, blue color, that part is a system, this is a boundary. Okay, so system has its boundary. The boundary may be a physical boundary or the imaginary boundary. Okay, so then it is the surrounding. Everything external to the system is called as surrounding. Then system, surrounding together forms a universe, is it? So system and surrounding together called as a universe. Okay, so let's see this one more, the practical examples I will show you here. So regarding this system, here the flask inside which the chemical is present. Okay, so this chemical is our system. Now I want to study the behavior of the chemical. So means my focus is now on the how the chemical is get behave, which is stored in this flask. That is becomes my system. Okay, then it has its boundary now. So that is its a system boundary. So that is the system boundary, and it get everything external to this flask is a surrounding. Is it? So I hope you understood now that what is the system and what is the surrounding. Let's see how we are going to classify this, the thermodynamic system. So systems are classified into mainly three types, that is the open system, a closed system, and isolated system. Okay, in the open system, what is it, where both the already you learned this, what is a system. Okay, so now in the open system means both the energy enters the system and leaves the system boundary, crosses the system boundary here. Similarly, mass is also enters into the system and leaves out of the system. It means both the energy as well as the mass crosses the system boundary, isn't it? So similarly here the closed system is one in which only the mass is remains fixed, energy crosses into and out of the system. From the surrounding, the energy enters into the system and leaves out of the system. And isolated system is one here, neither mass nor energy crosses the system boundary. Okay, so few examples for this, the different types of systems we'll see in the next slide. So that is, these are the day-to-day life examples where for the open system, closed system, isolated system. In the open system, the first examples, evaporator, then the passengers, train when stops at a platform, then the pressure cooker once it blows, the throttle valve, tree, printer. Similarly, in a closed system, a refrigerant in a refrigerator, the pressure cooker till it a pit cock blows, the IC engines during the compression stroke, then the boilers, the baking of bread in an oven. Similarly, fan, and then isolated system, the thermos flask. Okay, so these are what the few examples. And here in the engineering, when you come to most of the engineering, the equipments are of open type only. Here both the mass and the energy crosses the system boundary. Okay, so fine. Let's see now in the next slide we are going to discuss now about what are the thermodynamic properties. At the beginning in the first slide we have discussed that the properties. So any measurable characteristic of the systems are called as a thermodynamic properties. So again these thermodynamic properties were classifying into two types, that is intensive and extensive the properties. Intensive system are one which are independent of mass or size of the system. Okay, then extensive properties are those which are dependent on size or mass of the system. Ultimately in single we can say the intensive is the property which those are independent from the size or mass of the system, and that extensive properties which are dependent on the size or mass of the system. So few examples for this, the properties we'll see in the next slide, that is intensive, extensive. See here in the intensive few examples I have given, and similarly in the extensive properties we have given some examples here. What the intensive says, a property do not depends on the amount of the matter in a sample. Similarly a properties depends on how much the matter a sample contains, isn't it? The first example you can see here, the temperature, then a boiling point, then concentration, the luster. So these are what the examples for the intensive system. If you see here, take an example as the temperature. Here the example as a temperature, in the temperature does not depends upon the size of the system. If you take the hot water in a 1 liter bottle or 2 liter bottle, whether the temperature is going to be changed? No. If it is a 1 liter bottle also temperature 50, if 2 liters is also it shows a 50 degree only. It means that the temperature is one of the property which does not depends upon size or mass of the system. Similarly a boiling point. If you take water, obviously water will boil at 100 degrees Celsius at atmospheric pressure of 1 bar. Okay, so whether if you are boiling the water in a container of 1 liter or 1000 liter, okay, but the boiling point will remains at 1 bar is 100 degrees Celsius only. It means the boiling point is also does not depends upon the size of water. It is also one of the intensive property. Then similarly a concentration is also does not depends upon the size. The luster of the ruby is also does not depends upon the size. Whether it is a small size ruby or the big size ruby, the luster does not affect it. It does not depends upon the size. Similarly the few examples of the extensive properties, so that weight. Obviously weight is depends upon the size. As any quantities are heavier, it's the lighter, its weight is less. If it is a heavier, the weight is the more. It means that it's the weight is the quantity which depends upon the size or mass or the matter of the system. Similarly length, okay, it also depends upon the size or of the system. You can see here the two balloons inside which the gas is filled. See here the small balloon and the bigger balloon. In the smaller balloon, the volume is not equal to in the bigger balloon. It means that it also does not, that depends on, it is the size. Here this is also example for the extensive properties. Similarly the entropy is also one of the example for the extensive property. Okay, so thank you.